Let's take another example. This time it says, what is the cosine of 30 degrees? And rather than just punching that into your calculator, I think you can all do that, but rather than doing that, I'd like you to see if you can figure it out from the right triangle. Remember what cosine is. Cosine, you go back to SOHCAHTOA. Cosine is adjacent over hypotenuse. Therefore, the cosine of 30 degrees is the side next to the 30-degree angle, which is x square roots of 3, divided by the hypotenuse, which is 2x. When we do that, the x's cancel out, and you're left with the square root of 3 over 2. And those of you that had pre-calc already, you memorized that the cosine of 30 is the square root of 3 over 2. That's something you had to memorize. In this class, you won't need to memorize it, but we certainly on our calculator can plug in the square root of 3, divide that by 2, and get a decimal answer. It's equal to 0.866. All right, so this is 0.866. And you can try on your calculator just punching in cosine of 30 degrees, which I'll do. If I take cosine of 30, notice I get exactly the same answer. All right, so cosine is just adjacent divided by hypotenuse, and we get an answer there of 0.866. Let's try another one. What's the tangent of 60 degrees? And again, I'd like you to try it without using your calculator. Now, notice the 60-degree angle would be the top right angle. It's not labeled, but if the bottom left is 30, the top right has to be 60. Take a minute to try to work that out. This is what you should have written. The tangent of 60 degrees, and that's read tangent of 60, not tangent times 60. We're not multiplying them together. We're taking the function of 60 degrees. And if you remember your SOHCAHTOA, the TOA part tells you the tangent is the opposite side over the adjacent. The opposite side was the x square roots of 3. Here's our 60-degree angle. The opposite side, x square roots of 3. The adjacent was x. So if we do x square roots of 3 divided by x, the x's cancel out. We're left with the square root of 3. And once again, we can do the square root of 3 in our calculator. I do the square root of 3. That's equal to 1.732, which is the exact same thing I get if I plug in the tangent of 60 degrees. Try another one. This time, what's the sine of 45 degrees? So this time we have a little bit different triangle. This angle is 45 degrees. And this angle also has to be 45 degrees, right? They have to add the 90 degrees. So what kind of triangle do we have if we have two angles the same? Remember, if you have two angles that are the same, that has to be an isosceles triangle. That means the legs have to be the same. So if this is x, then this other leg also has to be x. And you remember what the hypotenuse is equal to in a 45, 45, 90 triangle. The legs are both the same. They're both x. Remember, if that's the case, the hypotenuse is always whatever the leg is times the square root of 2. It's x square roots of 2. All right, so knowing that, what's the sine of that angle going to be? Sine of 45 degrees, sine, that's the SO part of SOHCAHTOA. Sine is opposite over hypotenuse. The side opposite the angle was x. The hypotenuse was x times the square root of 2. X's cancel. You're left with 1 divided by the square root of 2. And those of you that had pre-calc, you learned to write that as the square root of 2 over 2. You rationalized the denominator. There's no need to do that in this class because you can do 1 over the square root of 2 in your calculator just as easily as you can do the square root of 2 over 2. And if you try that in your calculator, you're going to get 0.707, which is the same thing you'll get if you punch in the sine of 45 degrees. This next example, this time we don't even know what the angles are. We have a 3, 4, 5 right triangle. Legs are 3 and 4. Hypotenuse has to be 5. using the Pythagorean theorem. But we have no idea what this angle B is. But that doesn't matter. We can still find the cosine of it, because to find a trig function, all you need to know are ratios of sides. So go ahead and find the cosine of angle B. Well, hopefully you said cosine is equal to adjacent over hypotenuse in SOHCAHTOA. The side adjacent angle B was the 3. The hypotenuse was 5. So you're left with 3/5, or as a decimal, that would be the same as 0.6. So even though we don't know what the angle itself is, we know that its cosine is equal to 0.6. All right, so that should have been choice number 4 there. Well, what if it's not a special angle? In this case, we have a 25-degree angle. And that's, who knows what the ratio of the sides is there. Well, if we have a special angle, if you're given the lengths of the sides, but not the angles, then you can use the ratios. In that last example, angle B was not a special angle, but as long as we know the lengths, we can use the ratios to get the trig functions. But in this particular problem, we don't know the lengths, but we know the angle. So if you're given the angle, simply use your calculator. So what's the tangent of 25 degrees? And if you do that, you should find that the tangent of 25 degrees is equal to 0.466. Many times, you'll know an angle, you'll know one of the sides of the triangle, but you're trying to find one of the other sides of the triangle. In this case, we know B is 6, we know the angle here is 25 degrees, but we don't know the length of A. This is a very practical thing that happens over and over again in physics. So what we know is an angle and the side adjacent to the angle. What we don't know is side A, which is the side opposite the angle. So to get side A, you have to think about, well, what trig function relates the side opposite that I don't know to the side adjacent that I do know? Is there a trig function that relates opposite to adjacent? And the answer is yes. If you think back to SOHCAHTOA, it's the tangent function that does. Tangent's equal to opposite over adjacent. So in this particular problem, I could say I know the tangent of 25 degrees is equal to the side opposite, which is A. I don't know that. Over the side adjacent, which is the 6 meters. I do know that. So tangent of 25 is equal to A over 6. I'm trying to find A. So what I'm left with is an algebra problem. To get A by itself, I'd want to multiply both sides of the equation by 6. And if I do that, I'm left with A is equal to the tangent of 25 degrees times the 6 meters. But that's something I can do in my calculator. If I do the tangent of 25 degrees is times 6. That's how I want to put it in. I'm left with 2.8 meters. So let's try this example. Let's say we're given that now side A is equal to 6 meters. We're trying to find the length of side B. Go ahead and see if you can use trig to figure out the length of B given the length of A. So once again, you're going to use the tangent function. This tangent relates opposite to adjacent, but this time you should have said tangent of 25 degrees is equal to 6 meters, because that was the opposite, over the unknown B, which was the adjacent. And now to solve for B, if I rearrange the equation, I'm left with B is equal to 6 meters divided by the tangent of 25 degrees. 6 meters divided by the tangent of 25. So if I go to my calculator, I do 6 divided by tangent 25, press enter, should have given you about 12.9. Or we could round it to 13 meters. All right, so the length of B we know is 13 meters. So knowing one of the sides and one of the angles, we can find the other sides. Very, very powerful technique. Let's try another one. So what trig function would you want to use? Take a minute to think that through and then work it out. Well, hopefully you decided to use the cosine function, because cosine is adjacent over hypotenuse, which would be 6 meters over C. If you rearrange it, solve for C, you're going to get C is 6 meters divided by the cosine of 25 degrees. So going back to the calculator, if I do 6 divided by the cosine of 25, That gives me about 6.6 meters, which was choice number 1 there. So here's a practical application of all this. Let's say you're trying to find the height of a tree. I actually had this experience. This is based on a true story. I live on a lot that is bordered by a wooded area, and one of the trees on the edge of our lot, at one point in time, it was looking rather old and it was dead, and looked like it might fall over. In fact, since that time, this is like 10 years ago, it has fallen over. But at the time, I was concerned about it falling over, and I was concerned specifically about whether or not it was going to fall into the house and do some damage, or worse yet, kill somebody. So the question was, how tall is this tree? And I knew I certainly didn't want to climb the tree to figure it out. And I didn't have a ladder tall enough to do it. So I thought, how can I estimate the height of that tree? And so here's what I came up with. I went down to the base of the tree and walked a certain distance away from the base. I measured that distance with a tape measure, right, roughly 10 meters. And then standing right here on the ground, I sighted up towards the very top of the tree using a yardstick. And using a protractor and a piece of string, I measured what this angle was between the yardstick and the horizontal. Actually, I measured the angle to the vertical, but let's say we know this angle to the horizontal. Let me just give you some insight into how I did that, because you may be wondering how that would have worked. Here was me, and here's the ginormous tree. And here's my eye, and I had this yardstick aimed such that my line of sight intersected the top of the tree. At the very edge of the yardstick, very end of it, I had a protractor taped to it, and I had a piece of string attached to actually a stone. Stone was at the bottom, and the purpose of the stone was just to pull that string straight down. And then all I had to do was, on the protractor, measure the size of this angle. And that angle would be exactly the same angle as this angle that the tree made to my line of sight. All right, so I knew this distance, and I knew this angle up in here. So very similar to the problem we're looking at right here. So let's go back to it. Assuming you know that angle and that side, go ahead and see if you can work out the height of the tree. The height of the tree is the opposite side of the triangle. It's opposite the 65-degree angle. So we're trying to find the opposite. We know the adjacent. So the trig function you should have thought of using was the tangent function. Tangent of 65 degrees is the unknown height over the adjacent, which was 10 meters. Therefore, the height of the tree is 10 meters times the tangent of 65 degrees. And if I work out in my calculator what 10 meters times the tangent of 65 is, that gives me about 21.4 meters, right, which is choice A. And to finish the story, I did all this. I worked out the height of the tree, and I found out that the tree was not tall enough to hit my house if it fell over. And a few years later, sure enough, it did fall over. Unfortunately, nobody was outside when it happened, and nobody was hurt.